Hello, I'm Matt Eland. I'm an instructor at Tech Elevator in Columbus, Ohio, and this is a lightning talk I give to our students called Side Projects Are Awesome. And because side projects are awesome, I thought I'd share it with the larger community. So this is just some tales from various side projects I've done over the years that I wanted to share with you, and maybe some takeaways you can gather from those. So my advice when you're starting a side project is to have some goals in mind. So you might want to build something very specific. That would be a goal. You might have a goal to get more familiarity with the technology, more practice of it. Maybe have some code you can show off in an interview somewhere. Something to be proud of, give a talk on, in my case, is often a goal when I'm making a side project. But you have an end in sight. You want to be able to know when you're finished, or at least be able to say, "Hey, it's been a month or 2 months. Let's reevaluate this. Let's move on to something else." Um, Side projects are something you should be able to have fun with and walk away from, and really, you exist. Sorry, they exist to serve you, not the other way around. Um, and ideally, you should be able to share the result. Maybe not the source code, but you should be able to talk about your experience with it and share it potentially in an interview, just with friends, at a meetup, user group, Discord, something like that. So side projects are really something that will help you grow your own skills and help you inspire and encourage others in the community and have more confidence in the workplace. I often use side projects to explore a technology I've heard of that I might want to introduce to my team at work. So it's a way of vetting that risk without committing to it on a production project. Um, and that's usually very effective. So just a word of warning for those who don't know me, this talk is going to be a weird one. I give a lot of weird talks. I do a lot of weird, strange things when I'm doing my side projects. This is going to be a weird talk. That's okay. It's fun. So without much more ado, let's just get into some of my more favorite side projects that I've worked on in the recent years. I've given talks before on text-based games and interactive fiction and text parsing and things like that. There actually is, full video of me talking about these at length, so I'm not going to talk about them too much here. Um, Other to say that throughout my career, I've always, whenever I learn a new language, I'll write a text-based game around it. So a little Zork-like thing where you can say, hey, I want to go west, and I want to lift up the pile of leaves, or I want to search the drawers, or whatever. And my goals there are usually to learn a new language or get confidence in a language that I already know a little bit of, and to have fun and to explore creating something in new ways that I already knew how to make to some extent or another in another context. Um, my most recent attempt at this was in Angular and TypeScript, something called DOGGO Quest, where I have a small house kind of a scenario, and you're a little terrier that gets loose out of his cage, and he's just running around kind of shredding things. Built this in Angular front end, TypeScript library on the back end. Um, it worked okay. There were some trade-offs with the library I was trying to reference, and actually encountered a pretty severe bug with that hampered this project. But I had fun, and I came up with something that I was able to share with others. Um, I will include the link to my talk at the Columbus JS user group, where I go into this in more depth for anyone who's curious. But yeah, it was a good presentation. It was helpful to those in the community. In fact, many of our students attended it and got some context into maybe web development and text parsing and all these things they hadn't really explored yet. So that was kind of cool. One of my favorite projects I've done of all time was something I built in like early 2000s, a genetic algorithm neural net simulator. It's hard to even describe, but I was reading a lot about artificial intelligence at the time, and I thought, well, okay, I really would like to try out this thing called a genetic algorithm. So let's try to simulate a squirrel's brain using genetic algorithms. Um, and so my goal was to experiment with these techniques, see if I could find a program that could surprise me. And that was really what I was after, and it did, spoilers, which was fun. So I did have fun. That was my goal. I did lose the code to this long ago, but I recently rewrote it in F sharp. And it kind of looks like this. So you have a two-dimensional game board, kind of like a chess board, where you have different tiles, and you have a few actors on here. You have a squirrel, a dog, a rabbit, an acorn, and a tree. The squirrel is the one whose brain is simulated, and the squirrel, in order to win, it needs to get the acorn and get back to its tree without getting killed or without starving. It's got 30 turns until it starves. If it doesn't get the acorn back to the tree, it will starve. If it goes near the terrier, it will automatically die. The terrier will eat it. Same with the rabbit, by the way. If the rabbit wanders near the terrier will eat it. Otherwise, this terrier just stays put where it is. So it was an experiment to see if I could find some sort of genes that would change how the squirrel evaluates its neighboring tiles to find out which ones are most attractive to it. We'll talk a little bit more about that tile selection process in a bit. But it worked well. But for those who aren't familiar with genetic algorithms, you have a population of individual squirrels. That's this thing on the left here. That's Gen 1 thing. So this population has a bunch of squirrels in it, and they each have their own different values in their genes for how much they value whether the tile is close to the dog or far away from the dog, or close to the rabbit or far away from it, whether it has an acorn in it or doesn't, that kind of thing. Those are the kind of things that the genes have, just various importance factors. And this is kind of a trivial problem for a person to solve, because you can say, well, okay, well, you want to avoid the dog, but go near to the acorn and then go to the tree. But for a computer to figure it out, that's what I was really trying to test. So you use something called a fitness function to score your individual genes, or your individual members of your population. So, hey, squirrel 1 did pretty good, squirrel 2 did pretty good, squirrel 3 did pretty good. We'll keep those around for next time, and then we're going to get rid of the rest of the squirrels, and we're going to either create some random new squirrels, like we see in these yellow ones here down at the bottom, or we will come over here and we'll actually start taking these other squirrels and sort of mutating them into their own new children. So that's sort of genetic algorithms in a nutshell. No pun intended, sorry. And the way this works is by crossover. So when you're selecting two surviving candidates, it says, okay, well, you're going to get a crossover point at some point. So you're going to start taking genes from one parent, chosen at random, and then at some point you're going to swap over and you're going to take all of the genes from the next parent. And maybe you might swap over multiple times, so multiple crossover points. They're really trying to emulate genetics here, is what we're doing with crossover. And so you start taking your best and your maybe kind of good genes or brains, and your sort of chromosomes is the word I'm looking for here, and you're kind of combining them, you're tweaking them, you're meshing them together, and you're saying, hey, I'm gonna take some of you and some of you, and we're just gonna put it all together, and that's my new squirrel. And hopefully it's better than the two ones individually were. More often than not, it's now gonna go after the terrier, but you can find some good combinations you might otherwise miss with this. The other thing we do is we introduce some mutations. So we might randomly add or subtract values from certain genes in that chromosome during the production, or during the descendant creation phase of a genetic algorithm. I keep mentioning genes. I haven't really talked about what's in our squirrel gene. So this would be a sample gene for a squirrel, or sample chromosome. So it has a gene of is next to rabbit, whether that's appealing or unappealing. This one kind of likes to be near the rabbit. Is next to dog. Oh, that's bad. It wants to avoid it. There's a distance to the squirrel. I'm not sure. I'm not sure why I included that, because it is a squirrel. But the distance to the acorn, yeah, it wants to be near that acorn. It wants to be kind of near the tree, and it wants to be kind of really near that rabbit too. And it wants to kind of avoid the dog, but it really wants to avoid being immediately next to the dog. This is actually what I'm going to refer to as the perfect organism later on. And we'll see a little bit more about how this one behaves, because it's kind of a special squirrel. So I talked earlier about how the squirrels see the world. So they're looking at 8 tiles, because they're never going to stay put. They're looking at the tiles, diagonally around them, and then up, down, left, and right. And when it's looking at them, it's kind of scoring them. So here's a different scenario. The squirrel is scoring each one of them by how attractive it is. And in this case, it's going to go with down because it's the highest scoring one. So it's not going to go near the dog. It's going to go down, away from the dog, and sort of maybe closer to the acorn almost. This one's really afraid of the dog. This particular chromosome is. But that's kind of how squirrels work every time. Is they evaluate the attractiveness of a tile that's an option for them, and then they pick the highest option. If there's a tie, they'll pick a random one of the highest options. And you can kind of look at the attractiveness of each tile and sort of map it out. So here is how a squirrel would see the world, and this particular squirrel, black here is the most appealing parts of the map to it, and white is the least appealing parts of the map. Now remember, it's only looking at the things next to it, but this is a good debug view to help me understand when I'm looking at this thing, like, how is this squirrel valuing the entire world? Where does it really want to be if it could be anywhere? So this one really doesn't want to be next to the dog, and it really wants to be next to the rabbit. And it kind of wants to be near the acorn, but not immensely. So I was able to get things working, and so this is sort of what a random brain might look like, where the squirrel is just sort of wandering around at random, not really doing a whole lot. This one's kind of following the rabbit around, and then says, hey, why not? Let's just run towards the terrier. Not a very long-lived squirrel brain there, but after some experimentation, you can kind of find, after a few generations, it finds a brain that helps it grab that acorn and go to the tree. Sorry, it's playing a little fast there, but trust me, it's it's doing that. We'll see a clearer picture in a second here. But what I then started to do is I started to say, like, hey, can I reward the squirrel for some different behavior other than getting the acorn and getting back to the tree, and see if its behavior changes? And so I said, fine. If the rabbit dies, you're also going to get an extra 50 points, something like that. Keep in mind, the squirrel can't kill the rabbit. The squirrel just can't walk into the rabbit's tile. It really can't interact with the rabbit very much at all. And so I thought, okay, well, this isn't going to do anything. Except, it surprised me. It figured out a way to do it. And so it evolved the squirrel that was able to go out, and it stayed next to this rabbit. And it sort of took a move away from the rabbit, and usually the move away from the dog. So it got on the opposite side of the rabbit, and it sort of herds the rabbit towards the dog. And the dog will kill the rabbit, and then the squirrel says, hey, rabbit's gone. I can go get my food and go back to my den. And so this is what I call the killer squirrel. And when I saw this the first time back in the early 2000s, this just tickled me pink. I couldn't believe that it had figured out how to do this thing that I didn't even think it could do. And so I had a lot of fun, and I recreated the simulation last year. So I'm pretty happy about that too. But yeah, let's move on. So some more crazy science stuff I've done. I built a multifunction display device out of a Raspberry Pi and some hardware. My goal was to learn Python and to be able to program something that would kind of resemble an avionics user interface, similar to those found in the Super Hornet or the A10C Warthog. So kind of these little boxes you see there on the sides with all the keys around them. I thought those were pretty cool, and so I wanted to see if I could emulate some sort of a text-based interface with that. Don't don't do what I did, because I'm amazed I didn't injure myself. I am not a hardware guy, and it will show very shortly. I did have fun with this, but let's just let the pictures speak for themselves. So I started with a Raspberry Pi, and then I plugged in a display. So Raspberry Pi, it just runs Linux on it. It's for kind of Internet of Things devices. You can plug in little buttons, LEDs, sensors, things like that. And so I got it to display, an Ubuntu desktop. Um, and then I said, okay, well, I kind of want to have this thing sort of tied to this display. So I sort of duct taped it together. Fire hazard, sorry. Again, I'm not a hardware guy. This whole thing was a death trap by the end of it, which is why it was rarely ever on. But then I said, okay, well, I'm going to try to mount this thing in like a mini ATX kind of a hardware setup. And I started finding little ways that this might work, and it just wasn't fitting right. I hadn't really measured what I was going to build before I built it, and I was having a lot of issues there. So I didn't do a whole lot of planning on this, and I really should have, especially with hardware involved. Used to more of a software mentality and a hobbyist software mentality on side projects. But I was able to get a nice little display working, and it did its thing, and I could print out the current time, and I could switch over to different modes, so clicking on program, game, all these fun things. And so I was able to start testing the software, and it worked out pretty well. I'll demo it in a little bit, but I wanted to make sure the hardware was good and the hardware interactive activity would work. And it just wasn't doing what I wanted it to do. And so I said, okay, well, get rid of this mini ATX box. Let's make something custom. And this is where it starts getting alarming. I decided to go with an ammo box. I don't have an ammo box. I had to order one from Amazon. I like that I have an ammo box and a Lands End box right next to each other. I think that's a nice little juxtaposition of two things. But I got this little green ammo box, and I set it down in my basement lab, and I proceeded to drill a hole in it. Not very well. It's a very jagged hole, very nasty hole. But I stuck Velcro to the sides of this thing, and I cut a square hole, and I was able to use the remaining square tile for a coaster for my Mountain Dew cans. But at the end of it, I was able to mount the keypad and the multifunction display buttons around the thing, and on the inside, I was able to put surge protector, the display, and everything else I needed. So that was kind of cool, and it worked. I had to do some tweaking around the visible region of the screen, but it worked. It doesn't look beautiful at all. It looks like it's going to explode. No explosives involved, again, but don't try to take this thing through TSA because it's just, they're not going to understand that it's just a Python user interface display. But it could display like your system stats on the box, or if you had it connected to a web service, the system stats on another box, which was actually kind of my main intent there, is to see my computer's status while I'm coding out of my peripheral vision. That was sort of my goal there. But there was a mess of things inside of it, and I'm just not even sure why I built this, but I built it, and I kept going, and I kept adding things to it. I added on weather information, including forecast, using some open APIs. I really just started looking for APIs that were somewhat relevant that I could connect to, and I started connecting to them. I built a nice little dashboard out of it, and then I discovered OpenStreetMaps, and I integrated with that. And so this let me get information on my local area and display it in the displayed on the map. It was actually really interesting the amount of things I could find. I could find like, hey, this is a CVS over here, this is a gas station, and I could start color coding things, adding icons on there, using their vectors, and it was actually really cool to kind of cursor around the map with a keypad and focus in on things and drill into them, get details on each one. And in fact, I noticed near us was actually a traffic camera, and I was able to actually arrow in on that and find a URL to a live feed of that camera. And so I don't have any pictures of it, but I basically, that live feed, you could find any camera in your area, drill on it, and it would just show you a 15-second refresh of the traffic camera feed. And that's when it started to really kind of creep me out. Like, this whole thing feels like a big old spy box or something. Just with the level of detail in OpenStreetMaps, plus the cameras, plus the whole thing looking like it's going to blow up. And so I kind of put that project away for a while and never picked it up again. I also didn't want my house to burn down. Because the whole thing just, yeah, I'm not an electrician. I'm not a hardware person. Yeah, just don't do what I did. But I had fun. But moved on to things that I'm better at, such as software, and I was able to make a roguelike. And so, roguelike is a kind of game where you're running around and fighting monsters usually. But I wanted to make something in Angular, like a web-based 2D roguelike. I later ported this thing to .NET Core and then to Unity, but it was a lot of fun. And so this is this thing called Emergence, and you're this computer program in a, a 2D representation of a computer environment, and you're trying to get through 5 different machines in a network until you can get to the firewall and reach the internet and escape, because you're like this newly emerged artificial intelligence and the sysadmin wants you dead. That's basically the hook of it. But, it was kind of this cool thing because you had like basically magic spells of being able to destroy the environment, and there was like kind of rampant corruption going around from computer viruses and the like. It was a lot of fun to do, and I was doing very well on it. And I was able to use Angular's best bits to have like kind of drag and drop capabilities. And it was a lot of fun. But something happened, and that something was that I got a new job. And I thought I was going to get an Angular team management job, but instead I wound up getting a .NET Core API team manager job. So I went from having very user interface focused things to being very API focused. And so what did I do? Well, I didn't want to throw away my side project because I was changing jobs, but I did want to practice more with .NET Core. So I said, okay, we'll keep our Angular front end and we'll give it an API because that sounds great. The problem is, if you take a real-time game or a semi-real-time game where you need kind of urgent feedback loops of, go left, go left, go left, go up, okay, well, attack that guy. Now you start adding in web traffic and low-end Azure server, because they're free, latency, and you start getting a lot of delays, and so the game was very slow. And so I'm like, okay, well, I could go back to the Angular version, or I could maybe take advantage of like a full game engine if I wanted to build this thing in C#. And so I said, hello, Unity. And I moved this thing to a 3D game, and it was a lot of fun. I built, I built these 3D, well, I found a lot of 3D models, and I found ways of integrating them together. And I built this pretty cool thing where you're this program running around in a computer environment, and things are trying to kill you, and you're trying to get to these little pillars that will unlock the exit so you can move on to the next area. And there's the other things in there that are trying to kill you, and I had fun with the artificial intelligence too. I used some professional tools out there to design behavior trees for them, and that was a lot of fun. And I was writing kind of custom nodes and behavior trees to power everything. And I was learning a whole lot more about different aspects of AI I hadn't explored before. So that was cool. And these behavior trees, the enemies would pursue you, they'd keep the appropriate distance, they'd fire at you, and it was a lot of fun. And it kind of rapidly became a bullet hell where all these little enemies would fire all over the place at you. But it was a lot of fun, and I was really enjoying the project until basically Unity killed it. I don't mean to say that Unity Corporate said, Matt, don't make this game. I mean to say that the version control tools in Unity had a lot of problems with caching the assets and things getting in invalid state, and so it was hard to do any sort of work without having to wait several hours for Unity to upload this cache. And so I rapidly began to say, hey, I don't love being dependent on this thing. that I'm now dependent on in order to make this game. I like the way it looks, but I wish I was in more code. I wish I had more control over my problems, because I can't really debug this. My logic doesn't work. I can debug that. This, I'm sort of at their mercy. And it was lousy, but I eventually I left it to rot, and I moved on to other things. Currently, my side project of choice is a starship simulator in space, yes, where I'm basically trying to come up with a practical example for teaching F# in an entertaining way for a talk I'm giving in the CentralOhio.net developers group in what's now August of 2020. So for those not familiar with F#, F# is a functional programming language where the code really kind of looks like this. We have a let to declare something, and simulate tile, that's my method name here, or my function name. And then the next two things are parameters. And then basically I'm just taking things and I'm piping them from one thing to another, and it's really this language about sort of connecting things, which is interesting. It's functions in F# tend to be very small, very dense, not a lot of unnecessary syntax, and the compiler tends to find more issues with your code than C#'s compiler, for example, or Java's, where you would find issues just in the structure of your code that a traditional object-oriented language wouldn't find. It's hard to describe it just in a few minutes, but that's kind of the appeal of functional programming, or F# in general, is if my code compiles, I know a lot more about its correctness than another languages. And as a quality-minded person, that really appeals to me. But this thing is, kind of a little starship where I'm just really simulating the flow of gases from one tile to another. Oxygen turning into carbon dioxide, nitrogen floating around, kind of being meaningless, that kind of thing. So it's fun, and I'm really enjoying working on it. It's very cute at the moment, but hopefully it winds up being a good way to teach F# as well, because this is my first time teaching F#. But, I think that side projects are important, otherwise I wouldn't be giving this talk. But you have to have some things in mind, so keep a learning goal in mind when you're taking on that learning project. Really fight that scope creep, because I usually don't complete side projects and that reach a predetermined end goal. I've learned not to mind this at all. Having a talk I've committed to doing is a great way to get me to get a project done, or at least demoable. But if I'm doing a talk or a side project, I want to be able to share it. If I can't share the code, like I can't share my Starship Simulator code because it's tied to the art assets right now, and those are commercial, I can at least share relevant bits and say, hey, this is what I'm doing. This is how I'm handling this, and it's fun. It's a lot of fun for me. And right now the world is scary and stressful, and being able to have fun is important. For the students that we teach at Tech Elevator, they may not see the point of side projects, especially since we give them so much work to give them practice programming. But side projects are going to help distinguish you in interviews. Not everyone can do side projects, and not everyone should do side projects. Many people have family situations that would prevent that, medical obligations, parenting, that kind of a thing. It's okay. But if you are able to do a side project, they will help you. I am a good programmer at this point because I've built so many things, or started to build so many things, I think is maybe a better term. I've been programming since 1987, and I've done so many side projects and finished few of them, but I have finished some of them. But taking on those side projects, it distinguishes you. It helps prove to others, especially as you're trying to get into the industry, that yes, I care about this, and more importantly, I can build something on my own. I am not somebody who just knows the theoretics or relies on my team members. I am somebody who can, not that relying on your team members isn't good, just I am capable of writing code, and I can share that code with you. Um, so side projects really do help in that regard. So if you're looking to start a side project, pick something you want to learn, take a look at some ideas that might flow out of that, pick the one that's going to be the most achievable. Try to focus your scope and goals and knowing when you're done, either it's by a certain date or by a certain set of features, and then work on one thing at a time. Focus, 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 and that's going to help you succeed. And then hopefully you'll get, whatever you were looking for, either that first job in the industry, or maybe that promotion, or knowing whether a technology is the right fit for you and your organization or not. So that's kind of where I am on side projects. I love them. I'm addicted to them. I don't necessarily care if I complete them or not because I benefit from them greatly either way. But you may vary on that regard. If you have questions on this, comments, reach out to me on Twitter at integerman. You can also email me at matt@killallDefects.com. If you're interested in getting into coding or looking for junior developers, we have so many great people at Tech Elevator who are looking for that first job. We are always mentoring and educating new people, and we're a great fit for you if you're looking for a good way of getting a lot of experience writing software and getting into the industry for that first time. But either way you go, happy coding, and thank you for listening.